Hello friends, welcome to the channel Base Your Btech. So last class we discussed two problems from this same question paper, KTU question paper June-July 2017. So today let's do two more problems regarding del operator. So here is the question, 22nd and 23rd. Show that F is a conservative vector field, also find its scalar potential. So let's copy this down. So let me tell you that conservative field means del cross F. That field, when we take the curl for that particular field, it becomes 0. So actually this conservative vector field is an irrotational vector field. Okay. So del cross F equal to 0. We have to prove del cross this vector must be equal to 0. So how to take the curl for this function F? We have to take the determinant of the 3 by 3 matrix, and if it is a cross product, the first row will always be ijk and the second row will be the ijk components of the first vector. Here it is del. So what are the ijk components of del? They are dou by dou x, dou by dou y and dou by dou z. Next is, the last row is the ijk components of the second vector, that is f. So here in the question it is given 2xy plus z cube and x square is the j component and k component is 3x z square. So let's take the determinant, which means first row, first column element, that is I cap, and when I cut the row and column of the corresponding element, we get the balance, this thing, that is dou by dou y, dou by dou z, x square and 3x z square. Next, negative j cap into determinant of this 2 by 2 submatrix, that is I have to cut this row and column corresponding to this j cap, that is then we will be left with dou by dou x, dou by dou z and 2xy plus z cube, then 3x z square, isn't it? So when I cut this row and column corresponding to this j cap, I get the remaining these 4 elements and I put it all together into a square submatrix. And next is plus k cap into determinant of, when I cut this row and this column, I will be left with dou by dou x, dou by dou y and 2xy plus z cube, then x square. So this is how we take the 3 by 3 matrix determinant, and now we have to take the 2 by 2 matrix determinant individually for each terms, isn't it? So just cross it starting from the bottom right corner, that is dou by dou y into 3x z square. Dou by dou y, here we have to take the derivative with respect to y. For which function? For this 3x z square. And luckily there is no y variable available here, so the dou by dou y of 3x z square is simply 0. Minus, now cross this 2, dou by dou z of x square. Again here we have to take the derivative with respect to z for the function x square. So when we take the derivative with respect to z, x is a constant there. So again it is a 0 coming over there. I put this minus here, then j cap. Now cross it, dou by dou x of 3x z square. So here dou by dou x, we are taking the derivative with respect to x. So 3 and z square are the constant. Now what is the derivative of what is d by dx of kx? It is simply k. So dou by dou x of 3x z square is simply k, the constant, 3z square there. So 3z square minus dou by dou z of 2xy plus z cube. Now again derivative with respect to z for 2xy, it is 0. Why? Because x and y are constants for this derivative with respect to z, and for z cube the derivative is simply 3z square plus k cap into cross this dou by dou x of x square is 2x minus dou by dou y of 2xy plus z cube. Derivative with respect to y, it is 2xy written here, so 2x is the constant there, and for z cube the derivative is 0. So again we will simply get like 0i minus 3z square minus 3z square, it is 0j plus 2x minus 2x is 0k cap. This answer is 0, which means our del cross f is equal to 0, hence f is a conservative field. Fine. Now the question has some extension, that is also find its scalar potential. Now what is this scalar potential? Okay. Scalar potential means we know that del phi is a vector, isn't it? That means if we take the gradient for a scalar function, we get a vector. Now if this vector is a conservative field, then we can call this phi as phi is the scalar potential of A. Condition is there, A must be a conservative field. Okay. So here we have proved that f is a conservative field. Now we have to find the scalar potential of this particular vector f. Okay. So we will have to write like del phi is equal to vector f. Now what is del phi expansion? It is I dou by dou x of phi plus j cap dou by dou y of phi plus k cap dou by dou z of phi is equal to, let's copy the f vector there. So here I have copied the vector f. Now next step is to compare the LHS and RHS. Why? Because in both sides you can see each vector. So let's compare the I components, j components and k components separately. That is, here the I component is dou phi by dou x in the LHS side, and in RHS side the I component is 2xy plus z cube. Next, the j component in LHS is dou phi by dou y, which is equal to x square, and dou phi by dou z is equal to 3x z square, isn't it? So now next, using these three expressions we have to get the function phi, isn't it? So the primary step is to remove this derivative, then only we can get our function phi, isn't it? So how to get rid of this derivative? Only way is to integrate it. Okay, so let's start from this equation. Okay, so from this equation, when I integrate both sides, what happens? And how do I integrate? I integrate with respect to x, because I am having a derivative with respect to x, isn't it? So let me integrate it with respect to x. So here in LHS side, when I integrate this derivative, this dou by dou x gets cancelled and we will be left with just phi. And here comes 2xy, integral 2xy plus z cube into dx. Okay. So how to integrate this? The basic equation, that is integral x raised to n dx is equal to x raised to n plus 1 by n plus 1, isn't it? So here integral 2xy dx, what is that? 2x square by 2y, because when we do the integration with respect to x, 2 and y are constant. 2 is already a constant and the other variable y is also a constant, should be treated as a constant. So for integral x is just x square by 2 plus z cube. Z is a constant when we integrate this with respect to x, isn't it? Because we have everything, we have started from a partial derivative, so we must take this z as a constant. Okay, so z cube x. Why? Because the other formula integral k dx is equal to kx. So integral z cube dx is simply z cube x. Now the integration part is not yet over. Why? Because we have to add an integration constant. So let that be a function. Why? Because here this function phi contains three variables x, y and z, and we have integrated this with respect to x, or we have taken the derivative with respect to x alone. So while taking the derivative with respect to x, y and z seems to be constant. So let the integration constant be a function in y and z. Clear? Why? Because the derivative here we have taken the partial derivative. So with respect to x, y and z are constants. So the function or the integration constant be a function in terms of y and z. Okay. So finally x square y plus z cube x plus function in y and z is your scalar potential, that is phi. And phi is the one which we are seeking for, right? Phi is the scalar potential. But still phi is incomplete because we have not yet found out the value of f of y comma z. What is that function? For that, in order to find that, we make use of the rest two equations. Okay. So phi is already there. Now let's take the derivative with respect to y. Okay. Just substitute this phi over here. So this becomes dou by dou y of x square y plus y cube x plus, sorry, that is z cube x plus f of y comma z equal to x square. Just a substitution. Now let's take the partial derivative with respect to y. So x square is a constant, so it becomes x square plus z cube x, isn't it? Z cube x means the derivative with respect to y, both are 0. I mean both are constant with respect to y. When we take the derivative with respect to y, both z and x are constant. So here it is a 0 there. Now plus dou by dou y of, we do not know the value of the function, or we do not know the expression, right? So let us write as such dou by dou y of f of y comma z is equal to x square. Now again by comparison we can get, here there is x square, in RHS side also there is an x square. But to compensate with dou by dou y of f of y comma z, there is nothing available in the RHS. So let's write a 0 there. Now when does a function's derivative become 0? When does a derivative become 0? When we take the derivative of a constant, isn't it? Derivative of a constant is 0. So f of y comma z must be a constant. But since this is a partial derivative with respect to y, this f of y comma z could be a function in z also. Why? Because when this f of y comma z is simply some function in z like z square or z cube anything, then dou by dou y of z square is still a 0. So we cannot write f of y comma z as just a constant number, but let us write it as another function in z. Okay, so let us write this f of y comma z as g of z. Why? Because we are very sure that this function does not contain any variable y, because if there was y, then we will have a derivative other than 0, isn't it? But since this derivative is 0, let us write the function. It can be a constant or any other function containing z in it. Okay, so that's it. So now function has been reduced, like f of y comma z is now g of z. Okay, now using the third expression, let me clear this. See, dou phi by dou z, that is dou by dou z of next I copy this over here, that is x square y plus z cube x plus g of z, okay, equal to 3x z square. Let's take the derivative with respect to z. So x square y term, here the derivative 0 plus with respect to z cube x. What is that? X into derivative of z cube is 3z square plus dou by dou z of g of z equal to 3x z square. Again by comparison we can have 3x z square in both sides. So the left term dou by dou z of g of z is equal to 0. Now derivative of dash is equal to 0. Derivative of a constant is 0. So of course this g of z must contain a mere number, is simply a constant, and no variable is there other than z. X and y is not there. Why? Because we have assured that this function g is containing only z. So g of z is equal to k. So let's replace again this g of z with k. Okay, so the function, finally the scalar potential is, answer is phi is equal to x square y plus z cube x plus g of z. Instead of g of z we must write a number k. So this is your scalar potential of the vector f. Fine. So let's take the next problem. 23rd, find the values of constants a, b, c so that vector f may be irrotational, okay, which means del cross f equal to 0. So need to find a, b, c such that del cross f equal to 0, and with that a, b, c substituted for f, find the scalar potential of f. So let's write the equation first. Del cross f equal to 0. Del cross f means determinant of a 3 by 3 matrix. Just put a wider modulus. I mean, we must accommodate these number of functions over here. So just have a greater space over there. Ijk, dou by dou x, dou by dou y, dou by dou z. Now the I component of capital F is axy plus bz cube. Next is 3x square minus cz, and finally it is 3x z square minus y. Okay, so now again I cap into, let's cross this, dou by dou y of this thing. Okay, when I cut this, you will get dou by dou y of this quantity, that is, here 3x square derivative 0 because we are differentiating with respect to y, isn't it? So dou by dou y of negative y is negative 1, and minus dou by dou z of 3x square minus cz. Again 3x square has 0 derivative, and dou by dou z of minus cz is minus c. Close it. Minus j cap into, now cross these two vectors, I mean this column and this row. So we get dou by dou x of 3x z square minus y, isn't it? Dou by dou x of 3x z square is, just take the constant outside, 3z square, and dou by dou x of negative y is simply 0, minus dou by dou z of this quantity. When we take the derivative with respect to z, axy is just 0 because x, a, y everything is constant, and bz cube. Dou by dou z of bz cube is b into 3z square. Fine. Plus k cap. So cut the rows related to this row and column of this k cap. Now it is dou by dou x of 3x square minus cz, it is 3 into 2x, that is 6x, minus dou by dou y of this quantity is, here ax is the constant, so ax, and bz cube has 0 derivative, so ax is the answer here. Now we must equate this to 0, isn't it? So all the three components, I cap component, j cap component and k cap component will be equal to 0, that is minus 1 minus minus c is equal to 0, and 3z square minus 3bz square equal to 0 from the j component side, and finally 6x minus ax, isn't it? 6x minus ax equal to 0. Okay, solving it out we get, this is minus 1 plus c, isn't it? Minus 1 plus c is equal to 0, so c value is 1. And 3z square minus 3bz square. So 3z square equal to 3bz square, b value is also 1. Finally 6x equal to ax. So a value is 6 by just comparing. So let's rewrite this capital F. Okay, our F value is now a is equal to 1, sorry, a equal to 6, b equal to 1 and c is also equal to 1, isn't it? That is vector f is equal to 6xy plus z cube I cap plus 3x square minus z j cap plus 3x z square minus y k cap. Let me arrange this. So here comes the vector f, and we know that this vector f is an irrotational one. That is why del cross f is equal to 0. And for every irrotational vector, we can get a scalar potential. That means del phi is equal to vector f. That is, phi is the scalar potential of capital F. Okay, so let's expand this del f. I dou phi by dou x plus j dou phi by dou y plus k cap dou phi by dou z is equal to your capital F. So let's compare this. Dou phi by dou x is equal to I component of this vector f, 6xy plus z cube. Okay, and next dou phi by dou y is equal to 3x square minus z. Finally, dou phi by dou z. In the LHS side, dou phi by dou z is equal to k component of the vector f, 3x z square minus y. Now we have to remove all this derivative and just get the scalar potential phi alone. So for that, let us take the integration with respect to x. So here it is phi equal to integration 6xy plus z cube dx. That is 6y into x square by 2 plus z cube is a constant there, so z cube into x. And we have to add one integration constant, and now that this is a partial derivative, let us write the integration constant in terms of y and z. I mean, let us write the integration constant as a function which contains y and z in it. Okay, because with respect to x, y and z are constant, so the integration constant is written in terms of y and z. I mean, a new function. Okay, so here it is 6 by 2, 3y x square plus x z cube plus f of y comma z is your phi value. So this is your scalar potential, but still f of y comma z is unknown. Let's find it with the help of next set equation. So dou by dou y of phi, let's copy this, 3yx square plus xz cube plus f. I am just writing f alone to save the space. Okay, so derivative with respect to y, 3yx square's derivative is simply 3x square plus xz cube has no derivative because the variable is y here. So it is 0 plus dou by dou y of f. So 3x square minus z. So here by comparison 3x square and dou by dou y of f of y comma z is equal to negative z. Okay, so how to get the f value here? This is having a little difference with the previous problem. So dou by dou y of f is equal to negative z. So now we are at the point that we have to find f, isn't it? So how to get rid of this dou by dou y? Just integrate this with respect to y. So here when I integrate this with respect to y, I simply get f of y comma z. Now this is equal to integral minus z dy. So it is minus zy plus integration constant. Now again, here the function is in terms of y and z, and we are taking the derivative with respect to y. So with respect to y, z is a constant. So let us write the integration constant, another function which is containing z as its variable. So we have now our f of y comma z as minus zy plus g of z. Okay, so I replace this f of y comma z with minus zy plus g of z. G of z is a new function. Now our next aim is to find out this g of z using the third equation. Okay, so before that I need to copy this phi over here. So I have copied the phi over to the third equation. Let me write it somewhere neatly. Okay, so dou by dou z of this quantity is equal to 3x z square minus y. Now let's take the derivative with respect to z. So here only y and x, so derivative 0 plus x z cube has the derivative x into 3z square minus zy has its derivative minus y plus dou by dou z of g of z. Dou by dou z of g of z equal to 3x z square minus y. So by comparison we can have 3x z square both in LHS and RHS, also negative y both in LHS and RHS. So we are now left with dou by dou z of g of z equal to 0. Now again here g of z contains only its variable z and the derivative is 0, which implies that g of z must be a constant, mere a number. Okay, so that's it. Now let's write this g of z, that's equal to k over here. Now our function, that is the scalar potential, is now ready. 3yx square plus x z cube plus f is actually minus zy plus g of z and g of z is k. So it is like minus zy plus k altogether, minus zy plus k. So here is the scalar potential. Okay, so that's all about del connected to this vector, scalar, etc. Now the next class would be from the theorems, that is Green's theorem, Stokes theorem, Gauss's theorem. So I hope you like the session. If you like the video, please do like, share and subscribe it. Till we meet in the next class, this is Minu signing off. Thank you and take care.